Hello, so today we're going to be learning about transforming literal equations, and there's a two-part video. Okay, but let's talk about what is a literal equation. A literal equation is an equation with two or more variables. But instead of like solving for a numerical value, like solve for x and get 2, we are going to solve for one variable in terms of other variables or in terms of another variable. And a formula is one type of literal equation and that has special applications in math and science. This is very, very important for those of you going on to chemistry and other sciences, because literal equations or working with equations and manipulating those equations is important. So there's all types, and we're going to start slow and look at some basics, okay? So I always like to look at the similarities between a linear equation and a literal equation. So for example, here's a basic two-step linear equation. The first thing we would do to solve for a would add 13 to both sides. We do the opposite operation. So it's being subtracted from a, so we're going to add it to the other side. We balance the equation out and we get 100. And then since the 2 is being multiplied to the a, we now are going to divide it to both sides. Whatever we do to one side, we do to the other, and so we get a equals 50. All right. With a literal equation, we're going to solve for a, but now there's going to be variables. Don't let it scare you. It's doing the exact same process. Here we had to isolate our variable. We isolated a. Here we're solving for a, so we have to isolate a. So in this case, very similar. The first thing we're going to do is add b to the other side. Now, c and b are different variables. They're not like terms. So what we end up getting is 2a equals c plus b. All right, then the next step would be, since 2 is being multiplied to the a, we're going to divide both sides by 2. So a actually represents c plus b over 2. And that is solving a literal equation for a variable. All right, let's try another one. It says solve for y. That means I want to isolate y. So I have to get that 2x to the other side. So I'm going to subtract it to the other side of the equation. That gives me y equals 9 minus 2x. And there I am. I'm done. It's no harder than that, okay? Solving for one variable in terms of another. All right, here we've got solve for m. Okay, so we want to isolate m. Now here we got to be a little careful. M and v are being multiplied. That right there is multiplication. So to undo it, we have to do the inverse operation. So I have to get v to the other side by dividing it on both sides. So p over v equals m. All right, so that's a those are basic literal equations. How do we apply this? Well, this year we've worked with this formula, d equals r times t. I want to remind you that's the distance formula. The distance formula. So distance equals rate times time. And it relates the distance of an object, d, to its average speed, which is our rate, and the amount of time it travels, which is our t. Okay? All right, so solve the formula d equals rt for t. So we need to isolate t. Well, r is being multiplied to t, so we are going to divide both sides by t. So that means that d divided by r will give me t. In real scenario, that means that if I take the distance, I divide it by the speed or that rate, I'm going to get the time that I spent traveling. So here's an example of where we would use that. How many hours would it take for a car to travel 150 miles at an average rate of 50 miles per hour? All right, so now remember, when we are taking a formula and we're solving, we should fill out all the variables. So I'm going to make a little side chart, which I want to see you do. So d is my distance, which is 150. R is my rate, so 50. And I'm looking for t. So t is my unknown. So I plug in each, or I substitute each value in for their variables. So 150 divided by 50 equals t. So to travel 150 miles at 50 miles per hour, it would take me 3 hours. So guys, the question was asking for hours, okay, which is our time. So that is why solving the literal equation here earlier and feeling comfortable with that made it just an easier problem, okay? All right, let's try it with more than one variable. So you have to understand what is being asked. If 3ax plus b equals c, find x in terms of a and b. Find x in terms of a and b. All that means is solve for x. And that means that a, b, and c are going to be in your answer. All right, so if I take 3ax plus b equals c, I have to isolate the variable. So the first thing I need to do would be to subtract b to the other side. Now you may notice that I rewrite that then. So I have 3ax equals c minus b. All right, now 3a is being multiplied to x. So to get rid of it, I'm going to divide both sides by 3a. So x equals c minus b over 3a. And there you've just solved a literal equation. So now we go to the multiple choice and we find our answer. This is a very similar question to what you'd find on a standardized test. Okay guys, so that's the basics of solving a literal equation. We're going to take that one step further in video 2 and then even further in video 3. Have a great night.